Okay, so this is Edexcel June 24, further maths, Core Pure 1, paper 1. And this is question 4. So this is a complex numbers question, a bit of de Moivre's theorem coming in here. It starts off quite nicely because it just asks you that if z is a complex number, so that it's e to the I theta, where theta is real, you need to show that z to the n plus 1 over z to the n is 2 cos n theta. So, first things first, we'll probably start off nicely with going, well, okay, so z to the n is e to the I theta raised to the power of n, and z to the 1 over z to the n, sorry, excuse me a minute, is therefore 1 over e to the I theta, oops, dear me, to the power of n. And so therefore that is e to the I n theta, and this is e to the minus I n theta. And then we convert it to its trig form. So e to the I n theta is just cos n theta plus I sine n theta. And this is e to the, dearie me, cos minus n theta plus I sine minus n theta. So we're now going to add those together. So z to the n plus 1 over z to the n is cos n theta plus I sine n theta plus cos minus n theta plus I sine minus n theta. We then recognise that cos of minus n theta is the same as cos of n theta. It's a little fact that we should know. But basically, we should know that cos of minus theta is the same as cos of theta. And we should know that sine of minus theta is actually the negative of sine theta. So over here, this is going to turn into minus I sine n theta, because sine of minus n theta is the same as minus I sine n theta. That and that cancel, so we get 2 cos n theta. Done. QED, we got that. Okay, so first part was worth 2 marks. We've now got to show that, and it's our classic expansion using z to the n plus 1 over z to the n, showing a trig identity. So let me just write up exactly what we have to prove. So I've got that in my mind. So cos to the 5 theta is equivalent to, excuse me a minute, 1/16 cos 5 theta, have I got enough room, plus 5 cos 3 theta, plus 10 cos theta. Okay, so technique really for this is to start off with this little expression here, and just remember, so from that we know that 2 cos theta is just z plus 1 over z. Yeah, with just our n being 1 there. So therefore, if we raise this to the power of 5, 2 cos theta to the power of 5, that will be z plus 1 over z to the power of 5. Now we do that because aren't we going to get a nice cos to the power of 5 theta there? But we're also going to get 2 to the power of 5. So that was going to give us 32 cos to the power of 5 theta is equivalent to z plus 1 over z to the power of 5. So we're going to have to do a binomial expansion on that, which shouldn't be too problematic. So when we binomially expand this, we should get z to the 5 plus 5z cubed. 5 just is 10. So obviously you can do this a bit longhand or whatever. You're going to get 10z. The z and the 1 over z, when they combine, is going to cancel down these to, then it's 10 over z, is that right? 5, 4, 3, 2, yep, and then it's 5 over z cubed, sorry, it's all down here, and then plus 1 over z to the 5, there. Brilliant. Okay, we're now going to group these together. The z to the 5 and the plus 1 over z to the 5. The z cubed and the 1 over z cubed, so that's 5 lots of z cubed plus 1 over z cubed. And finally, on the end there, we've got 10 lots of z plus 1 over z. Wonderful. Okay. And from our identity here, that is just 2 cos 5 theta. 2 cos 5 theta. I'll tell you what, let me put in my 32 cos 5 theta here, which we know this is all equal to. That is obviously 5 times 2 cos 3 theta. And this is 10 times 2 cos theta. Okay? So, what we're now going to do is just divide the 32 over there, and we get cos to the 5 theta is, this divided by 32 is a 16th, cos 5 theta. This divided by 32 is 5 over 16, cos 3 theta. And this divided by 32 is 10 over 16, cos theta. Take the 16th out, and lo and behold, we have what we want there. Boom. QED again. Okay. So it's quite a classic little procedure that you have to learn and comes up quite a lot. And usually what that then leads to is solving an equation, and sure enough, here we have an equation that we want to solve. Let me just have a little look. Cos 5 theta plus 5 cos 3 theta. I'll keep that up there because that's what we just proved. So for part C, we are now solving cos 5 theta plus cos 3 theta. Nope, 5 cos 3 theta even, dear me. And 12 plus 12 cos 12 cos theta equals 0. Okay. So, looking at this, we have got, if I rearrange this, cos 5 theta, 5 cos 3 theta, 12 cos theta, we've got 10 here, so we've got a little bit of a discrepancy between what they got up in our proof here and what we got down here. So let's start off by realising if I take the 16 over there, I'm going to get 16 cos 5 theta. So that and that out of this is going to give me 16 cos to the power of 5 theta. But I'm going to have 2 cos thetas left over because I'm only using 10 up for this identity. So take the 16 over there, so I've got 16 cos 5 theta, and that's what this is equal to. But I'm going to have 2 more cos thetas there. So let's get another plus 2 cos thetas there because I've still got them, unfortunately. Okay, right, if I factorise out the cos theta, so I get cos theta, I might as well factor out 2 cos theta, haven't I? There's a 2 there nicely. So that's 8 cos 4 theta plus 1 equals 0. So I either get, either that is 0, so 2 cos theta equals 0, or that is 0. So 8 cos to the power of 4 theta plus 1 equals 0. That leads to cos to the 4 theta equals minus 1 over 8. Oh dear, we can't have that. You can't have the 4th power of something giving you a negative number. So there are no solutions to that particular little one there. So we're just dealing with 2 cos theta equals 0, which is lovely. Just quickly check what they want this between, 0 and 2 pi. So inverse cos of 0 gives you pi over 2. So theta equals pi over 2. And then it's just down to your classic, do you use the graph? Do you use cast method? My own personal thing. You can work out the other value for cos. I mean, if you're a cast member, if you're cast people, then obviously it's there. So it's either pi over 2, the other place it's equal to 0 is down there. Where you want cos equal to 0, so it's pi over 2 or 3 pi over 2 is our 2 answers. Okay. There we go. Quite a nice question. Bit of an unusual that you kind of get to, oh, just these kind of simple answers. It just comes to 2 cos theta. We've got these that where there's no solutions. But that's it. Okay.